Hello everyone. Hello everyone. I guess you're fine. Yeah, I just want us to look at two concepts today. The first one is going to be on composite functions, and the other one is going to be on finding the critical points, determining the nature of the critical points, and sketching the graph. And then lastly, determine the interval on which f of x is increasing or decreasing. So that's the concept that I just want us to learn today. So we're going to start with the composite function first of all. So we're going to start with this part today. We are given that f of x is equal to 2x over 4 minus x, and g of x is equal to 1 over x squared. And the question is to find f of g and state its domain. So in this question, we are required first of all to find a composite function. Then after finding composite function, we are expected to state the domain. And now the question is, how do we go about this question, which is here? So to solve this question, what we are going to do is simple. Let me just in a different page. So now the question is to find f of x. F of x here, this is equals to this number here, this function here, f should be at the end. So what is happening here is you have an x, and then x is mapped to this function, which is g of x, and then g of x to this function f. So I say f of g of x like this. This is what is happening. So now to find this part which is here, we are going to say this function is equals to g of x like that. So now the question is, what is the value of this part which is here and the value of this? So what is happening here is every time when you're given a function of this type, say f of g, meaning that this is just the f and then g of x. If it was the opposite, if it was g f of x like this would have been, you would have ended with g and then f in g. So it is f, the function f, that you are inserting in the function g when it is like this. But when it is like this, it is the function g that you are inserting in the function of f. So now we are asked to find f of g, meaning that we have to start by finding f of x, and then after finding the value of f of x, we are going to replace this function in the function, whatever we are going to replace whatever we are going to get here in the function of f. So this is equals to f. G of x is equals to f of x is this. G of x is 1 over x squared. So we'll start by writing the function g of x, which is 1 over x squared. Now that we have written like this, what is following next is, in this function of f, wherever you are going to find x, replace this value here, 1 over x squared. So now in the function of f, wherever you are going to see this, wherever you are going to find an x, to see an x, just replace it, 1 over x squared. So now in the function of x here, we have 2x. So now where you are seeing x, you have to put 1 over x squared. So this is going to be 1 over x squared over 4 minus, this is over 4 minus 1 over x squared like that. So now from here, we can simplify the top part. We can simplify this part here. When you simplify this part, we are going to discover that this is going to be 2 multiplied by 1 over x squared. So this is just 2 over x squared over the down part here. You find the common denominator here. As you can see, we have 4 over 1 minus 1 over x squared. So the common denominator here is x squared. So we are getting x squared as our common denominator. And then x squared, this is the denominator, which is 1. X squared dividing 1, the answer is x squared. X squared multiplied by 4, we are getting 4x squared like that. Next, we come to this part here. X squared dividing x squared, we are getting a 1. 1 multiplied by negative 1, the answer is minus 1 like that. So now we have this part which is on top, dividing the down part which is here. So if I tell you to simplify this further, you realize that this x squared, which is the denominator for this, and that x squared, which is the denominator for the first part, these two automatically cancel. So in short, you're only going to remain with 2 over 4x squared minus 1. So what I was trying to say is our f g of x, which is equals to 2 over x squared dividing 4x squared minus 1, dividing 4x squared minus 1 over x squared. This is equals to 2 over x squared multiplied by, then this is going to reciprocate, and you're getting 4x squared minus 1 like this. So this x squared and this x squared, they automatically cancel, and you're going to remain with 2 over 4x squared minus 1. So this is our composite function. So f g of x is simply equals to this part, which is here. So that is what we're required to do on this question. So let's go back to the question. The question was requiring us to find g of x, and then upon finding g of x, we're required also to state the domain. So we are required now to state the domain. So now how do we state the domain? That's the question of interest. How do we state the domain for a composite function? So guys, in order for us to state the domain for a composite function, let me just show you something here. Since our f of g of x, this part is equals to, this part is equals to 2 over 4x squared minus 1. So this is our composite function. So to find the domain for the composite function, what we are expected to do is simple. So we have f g of x. This is equals to f g of x. So now as we are stating our domain here, we are expected to state the domain for the inside part. And then after stating the domain for what is inside, for the function which is inside, that's when we state the domain for the entire part. So here we have to state the domain here. We state the domain for g of x. After we've stated the domain for g of x, you state the domain for what is inside. Guys, let's not swap the two here. You state the domain for g of x, and then after you've stated the domain for g of x, you state the domain now for this function which is here. So now when we look at g of x is equals to 1 over x squared, meaning that the domain for g of x is simply equals to all values except the value which is going to make this part, except the value of x which is going to make this part is 0. That's what we don't want. So now our domain here for g of x is going to be equals to x squared should not be x squared equals to 0. So meaning that x equals to 0. So whenever x is equals to 0, this part is going to be undefined. So now when we are stating the domain, when you are setting the domain, you're simply looking for the values of x, such that when you put them here, when you plug them where there is x, we are going to get the outcome value. We are going to get the outcome value. So now, if I tell you put 0 here, we're not going to have an outcome value, which is undefined. So therefore, as we are going to state our domain, we have to make mention that x equals to 0 here is going to be undefined. So meaning that the values of x which are going to be in the domain are all real values except x equals to 0. This is the domain for g of x. So now let's move to we move to the domain for the entire part now, the composite function. So number one, to find the domain for the composite function, number one, you have to find first of all the domain for the inside part, the function which is inside. And then after you found the domain for the function which is inside, that's when you find the domain for the outside function. So the inside function in our case is g of x, and g of x is equals to 1 over x squared. So the domain for g of x is equals to all values except x equals to 0, because when x is equals to 0, we are getting undefined. So we are done with the domain for g of x. Now let's move to the domain for the entire part here. So the domain for the entire part is equals to this part. The domain for this part here, which is equals to 2 over 4x minus 1, is simply equals to this part here, the down part here, should not be equals to 0. So meaning that we are going to say 4x squared minus 1 should not be equals to 0. So now let's find the value which is going to make it equals to 0 and factor it out. So we're going to say 4x squared equals to 1. X squared equals to 1 over 4. Like this. Let me write it on the other page. So we have fg of x here, which is equals to 2 over 4x squared minus 1. So here we are saying 4x squared minus 1 equals to 0. So we're simply looking for the value which is making this part to be 0 so that we factor it out. So when we do that, you're going to have 4x squared equals to 1, meaning that x squared here is equals to 1 over 4. 1 over 4, implying that x is equals to plus or minus the root of 1 over 4, which is just equals to x is equals to 1. X is equals to plus or minus 1 over 4. Plus or minus 1 over, the root of 4 is just 2. So x is equals to plus or minus. So when x is equals to plus 1 over 2, when you put it here, you are going to get a 0. So we are going to factor it out. Secondly, when x is equals to negative 1, also, we are going to factor it out. So the domain for this part here, we found x equals to plus or minus 1 over 2. And the domain for g of x, here, we found x equals to all values except x equals to 0. Because the moment x is 0, we are getting undefined. So the domain for g of x is all real values except x equals to 0. And for this part here, the domain here is all real values except x equals to plus or minus 1 over 2. So in short, therefore, the domain for this function f g of x is equals to, let me just write it on the other page. So the domain for g of x, I'll just say I'll use this domain for f of x, this fog f of x, this is equals to x all real numbers except those values which are giving us 0, except x equals to 0. You start with the domain for g of x equals to 0, and then the next value is x equals to plus or minus 1/2. So in this case, our domain is going to be x equals to 0. X belongs to all real numbers except x equals to 0 and x equals to plus or minus 1/2. So guys, this is how we find the domain whenever we are given a composite function. So don't forget, each and every time when you're given a composite function, for you to find the domain or the range, you first have to find the inside part. Find the range for what is inside. Is it g of x? Is it f of x? Find that range. And then after you found the range for that inside part, that's when you find the range for the entire part. And then you combine the two and then you give the domain at the end. Sure. So that's what you're expected to do. So this is about this first question.